Today is day 17 of learning computational astrophysics, and I focused on clustering. Clustering is a type of unsupervised machine learning where you give the algorithm data and no labels, and it tries to find structure and groups by itself. I mainly looked at k-means clustering, which is pretty simple. You first choose the amount of clusters you want, and each point gets assigned to the nearest center. These centers move to the mean of their group, and you just keep repeating until everything settles down. One thing I found quite interesting is that your result depends on how your data is represented. Since k-means is based on distance, if one feature has a much larger scale than another, it can completely dominate the clustering. This is when standardizing the data can make a really big difference. I also looked at the elbow method for choosing the amount of clusters and then compared k-means with mean shift. Mean shift clustering is a little bit different because you don't tell it the amount of clusters to find beforehand. Instead, it looks for dense regions within the data, and the result depends on the bandwidth you chose. I then tried this on gamma ray burst data using things like burst duration to see whether the bursts would naturally split into different groups. After that, I added fluence, which is basically the total gamma ray energy received per unit area over the entire burst. This was just to add another feature and see how the clustering changed when the algorithm had a little bit more information to work with. You can see everything I did in my Jupyter notebook. That's day 17. See you next time.